If you have a controller, this is what it looks like. Or this, I don't know which team you're on. But if you have an Arduino, then this is what your controller looks like. In this video, I'm going to show you exactly how I built this controller and even play some games with it at the end. Start was pretty simple. My friend was over, conveniently, and we made the first prototype of a board. So we made another one because I didn't like the old one. Yes, this is actually better. We rounded off the corners. This had some weird holes. Yeah, so this was garbage, so we made another one, which is 10 times better. Yay. And now I would glue 2 Lego pieces on the back and mount it onto the Lego part like that. So I thought it would be way better and easier for me if I sacrificed these 2 small Lego pieces and glued them here. After that, started the painstaking process of putting the button. And I say painstaking because it took like 3 tries. I was in my village doing that. I was trying to solder, which was a big mistake. I do not know how to solder. I don't. This is kind of what I'm going with. So with 2 holes without the solder, I'm removing the heads of the jumper cables, which leaves us with this, and it perfectly fits the male part of the button. First attempt kind of worked out. It was good. I tested it. It worked. So we wired this button, I mean all 4 of these, but the sample code only works for 1 button. So here, as you can see, if I press the button, it does that. How exciting. It moves. First flaw that I had was I decided to drill the holes to the side of the buttons and then route the cables that way, which was super ugly. Then I made the biggest mistake yet of this project. I decided to use grid method. Well, what's the grid method, you ask? Say you have 8 buttons. For 8 buttons, you need 8 wires, 1 for each digital input of a microcontroller. But grid method complicates the software, but simplifies the hardware. If you have 4x4 grid, you have 16 overlapping points. And this takes up 8 wires, 4 for x-axis, another 4 for y-axis. And if you position each button on each cross point, you get 16 buttons instead of 8. And this is what I tried to replicate. But because I didn't plan ahead, I ended up connecting every single button to every single wire. And when I pressed 1 button, every single pin fired. And now you think, well, you must have gone back to the original, using 1 wire for 1 button. And you'd be completely wrong, because for some reason, I decided to now plan ahead and do the same thing again. And if you say that it broke again, well, you'd be completely right, because it did. Well, after I took that big L, I came back to the city and started working on it. And this time I made sure to plan a bit more. And after I cut the 4th board, instead of gluing it straight to the Lego pieces, I decided to drill the holes first. And I also made sure to drill the holes directly beneath the button. So when the button was sitting on the board, wires were not visible. Now I'm going to tell you a random fact for absolutely no reason. Did you know that in Switzerland it's illegal to own 1 guinea pig because they get lonely and that's considered animal cruelty? So you gotta own at least 2. Yeah, so now you know. Now you know. And then I added a top strip for action buttons. Well, I don't know what they really are, but I'll call them action buttons because they perform actions. And I added 2 more buttons on top of the controller and the assembly was done. I also added these joystick mounts. It's just small wooden squares that would mount joystick modules on it. And this is how it looked like. Only thing left was the software part. Then I quickly realized that 10 buttons that I initially had for the controller were not enough Games for recognize it as a controller because it didn't satisfy the full layout of a controller. But then I had a stroke of genius. Well, you don't have to have physical buttons for the games to think that you have those buttons. You just need to fake them. So I did exactly.
Tell you what, I did absolutely none of those because then I realized Steam had its own calibration settings, which I could use to calibrate my joystick, even if I didn't have the full layout of the buttons. And would you look at this? Now it's finished and it's black. So let's go to, well, settings. Controller. Oh yes, aiming device. We have a controller. It didn't show the controller there previously. Wait, so okay, this is zoom and okay, this is shoot. Let's go Battle Royale Casual Z. The reason I'm connecting to zombies because zombies are easy target and I can like practice a bit. Okay, what's reload?
Loading new mag.
Okay, X is reload. That's not good because that button has some problems, issues. I basically don't have 1, 2, 3, 4, 5, 6 buttons. I'm lacking 6 buttons. A is parachute. B is cut the parachute. It is weird, man. Okay, we gotta grab with X, but my X has problems. Can we? No, I pressed the wrong button. Okay. Well, here's another guy.
Your squad made it to the safe zone. Gas is inbound.
Hey, our first kill. Okay, that was sad. This guy did not know how to play. Maybe it was a bot. Oh, whoa, 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 whoa. Okay.
Oh my god, bro. Oh, hell no, man. What the fuck?
Okay. It's just sad how bad I play with this. It's gonna take a long time for me to get the hang of it. When I stop, I can somewhat aim, but if I don't stop, I can't do shit. No. Okay, well, 6 kills is most I can get, I guess.
What are you talking about, man?
At the end of the day, you won't be able to play competitive games with this. Half the reason being it's built with Legos and is susceptible to spontaneous disassembly. And the other half being that half the time buttons don't work. But that's besides the point. Spontaneous disassembly.